Finally, we come to the last part in which we are going to form a quadratic equation by given roots. So what does that mean? So I'll just give you a very simple example like if I tell you that the roots of a certain equation, they are 1 and 2, can you form an equation for me? You need to recall the idea about solving equation in which in order to have roots 1 and 2, that means the equation should carry x minus 1, x minus 2 as its factorized form. So if you expand it, then you have x squared minus 3x plus 2 equals 0, and this is your answer. If you try to use calculator to find the roots of it, you will find that the roots are 1 or 2. Let's look at one more example. If it is in fraction, for example, like the roots are 1 over 2, or negative number, minus 3, we can do a similar thing. And the roots come from x minus half, as well as x plus 3 equals 0. And then if you expand it, it goes to x squared, and then there's plus 5 over 2x and minus 3 over 2. We rarely put fraction as coefficient or constant, so that's why I prefer to multiply 2 to all the terms, which give you 2x squared plus 5x minus 3 equals 0 finally. Hopefully this illustration is clear enough to you. Now we come to what if we have the roots alpha and beta this time. Okay, so the roots are alpha or beta this time. By the same logic, you have x squared minus, not x squared, you have x minus alpha, x minus beta, that's the equation. If you expand it, it's x squared minus alpha x minus beta x plus alpha beta. And if you group them in terms, that means you have minus alpha plus beta x plus alpha beta equals 0. But sometimes our roots may be different in locking, not necessarily alpha and beta, like example 25, like alpha plus 1, beta plus 1. Would there be any other way to present the equation marked in the green arrow? It can be rewritten as alpha plus beta, it is talking about the sum. So that's why you can say it's about sum of roots in front of the x, while you have products of roots as the constant term. And then this is the equation, how you can form a quadratic equation according to the roots. It's pretty hard to understand it, right? So let's take a look in example 25 to see the situation or see how we can use the formula. Now in the question, you see that the roots are alpha plus 1 and beta plus 1. In order to apply the formula, you need to find the sum of roots and you need to find the product of roots. So for example, example 25, okay, let's read. Okay, example 25. In order to form an equation, you need to check for the sum, alpha plus 1 plus beta plus 1, as well as you have to check for the product, alpha plus 1 times beta plus 1. And we now calculate it one by one. In the question, it tells you already, sum of alpha beta is 1, alpha beta is minus 2. So that's why you have 1 plus 1 plus 1, which is a 3. While the product needs to be expanded, which is alpha, beta, and 1. So which gives you minus 2 plus 1, which is a 0. So this is the sum of roots. This is the product of roots. So that's why the equation is x squared minus sum of roots x plus 0 equals 0. Right, if you simplify it, that means the equation is x squared minus 3x equals 0. Okay, this is the way how we can find the equation. Now let's try part B together as well. The new equation carries roots 2 alpha and 2 beta, so that's why we check for the sum, which is 2 times 1, which is a 2. We also check for the product, 2 alpha 2 beta, which is 4 alpha beta. That means it's minus 8. And finally, and now you can see the situation. This is the sum. This is the product. So that's why the equation is x squared minus sum of roots, xe, plus product of roots equal to 0. And finally, that means that the equation is x squared minus 2x minus 8 equals 0. Okay, grasp the idea properly. Now we come to take a look in example 26, and you see alpha beta are the roots of the equation, and you have to find the value of alpha beta. As mentioned before, first of all, don't look at the question, but immediately write down alpha beta first, which is sum of roots should be minus b over a. So the number is not good this time, it's a fraction, 15 over 4. While alpha beta should be c over a, which is 2. Then as a result, 1 over 3 alpha plus 1 over 3 beta, which is, by putting the fractions together, you have, what's that? Beta plus alpha over 3 alpha beta, which means, by calculator, you can do it quite quickly. I just write the step very shortly here. Finally, it's 5 over 8. That is, part A is a very simple one. Now we come to part B, and you need to form an equation of the roots 1 over 3 alpha and 1 over 3 beta. And then, so it also requires you that the coefficients, constant term, must be integers, like one example we demonstrated before. Now can you see that actually the sum, so it's already prepared for you. That's why in part B, the only thing missing would be I need the product in order to generate the equation. The product roots would be pretty easy because it's only 1 over 9 alpha beta, which is 1 over 9 times 2, 1 over 18. So that's why the equation would be, let's spell the formula, x squared minus sum of roots, xc, plus product roots, 1 over 18. And the question requires me to turn every fraction into integers. So that's why you need to find a number to cancel 8 and 18 respectively. And you search for the LCM, it should be, what is it? Yes, times 72. So finally it goes to 72x squared minus 45x plus, what should it be? 4 finally. And this is the equation which carries the roots 1 over 3 alpha and 1 over 3 beta, though you don't know exactly what alpha and beta are.